Hello friends, this video on chemical bonding part 17 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 16. So why lone pair repel more? If you see the lone pairs are localized in central atom itself. For example, this lone pair is the central atom itself. And when you talk about the bonded pair, this is shared across between two atoms. For example, this is my carbon. This is my hydrogen. So I'm talking about a lone pair, right? There's no lone pair in this. All are bond pair because this is a bond pair, this is a bond pair, all are bonded. So, and these atoms in a bond, as you know, in a covalent bond, you need 2 electrons, and these 2 electrons are shared. So if I'm talking about 2 electrons here, this is shared between carbon and hydrogen. But in this case, if you see, there is a lone pair, and these 2 electrons are as it is here in this, correct? In this case also, if you see, for example, this is NH3, I think, NH3, and this is H2O. So if you draw the Lewis structure for CH3, carbon is not having any extra electrons, but if you talk about NH3, it will be something like this, 2 electrons here. If you talk about H2O, it will have 4 electrons here, right? So since in this case there is a bond pair means that 2 electron I am talking about is shared, is between carbon and hydrogen, it has less effect. This guy, if you see, is totally sitting here. Here, this guy is totally sitting here, totally sitting here. So this guy is repel more, because they are not shared, they are totally here. That's why the lone pair, they want to occupy more space, and since they want to occupy more space, they repel more, correct? Because see, they don't have, they have to be, they need to get more space because they are only with this nitrogen or oxygen here, correct? There is no other atom sharing this electron, so they are totally with this, depend on this nitrogen. So this nitrogen has to give more space to this electron, two electrons. But in this case, since this 2 electrons are shared between hydrogen and carbon, these 2 electrons sometimes spend time with hydrogen, sometimes with carbon. So even if carbon gives less space to these electrons, they are happy. But in these cases, these electrons are totally dependent on nitrogen, so they need to give nitrogen needs to give more space to this electron. Here, if you see, there are 4 electrons, and they are totally dependent on oxygen. There is no other atoms they can go and sit, or they can enjoy. They have to come to oxygen, right? Though they need more space. Since they need more space, they repel more. Hope you understand. That means the lone pair needs more space. So the lone pair attraction will be maximum because both need more space. Lone pair and bond pair will be little less because this guy is little happy, this guy is not happy, and this will be all the more less because both are happy, right? So this will be the order of attraction, repulsion, maximum, and this will be. Hope you understand why it is like this. Since the lone pair is totally dependent on the central atom, they need this lone pair needs more space. Since it needs more space, lone pair attraction, repulsion will be more. Bond pair is shared between central atom and the terminal atom, so this doesn't need much space, so the repulsion goes down. So let's start with the Vesper theory. So let's start with the sp geometry first. So sp is a hybridization. Anyway, we'll discuss this hybridization later, so you can ignore this part now. So let's take this example of CO2. Here, if you see, if you draw the Lewis structure, there is no extra lone pair here, right? It's all straight. So this oxygen will try to repel, both will repel, and it becomes straight. Also, if you take example of BCl2, beryllium is not having any extra valence electrons, right? So they will repel each other and they'll become straight. there is zero lone pair. Correct? Something like this. So one central atom, carbon, and they are just repelling. Let's take sp2 hybridizations. So in this case, we have scenarios where there can be zero lone pair or one lone pair. So if it is zero lone pair, it will be normal triangle planar, for example BCl3 you see here. So boron has 3 valence electrons and all these are occupied by these 3 chlorine atoms. So it is not having extra lone pairs, right? So each of there is no lone pair here and they are all repelling all the chlorine molecules. So they get this shape called trigonal planar. But if you take this example of SO2, sulfur has so this guy has one lone pair here. So it will repel. Since it will repel, this will become 119 degree. See, it has to be 120 degree if it is a normal bond pair, but since this was a lone pair, it repelled all the more, so the angle from 120 became 119. Let's talk about sp3 hybridization things. So in this case, if you see, there are 4, for example in this case I have methane CH4, carbon with 4 hydrogen, and there is no lone pair on the carbon. So it's a normal shape I have, tetrahedral shape. I have one carbon. If I draw the Lewis structure, there is no extra lone pair on the carbon. It's normal tetrahedral structure. If you talk about ammonia, there are 3 here, but 1 lone pair is here. So it will bend. So instead of becoming tetrahedral, it will become trigonal pyramidal. Please note, it becomes trigonal pyramidal. If you take water, since there are 2 lone pair here in oxygen, if you see, and it will repel all the more. Since it will repel all the more, the angle will further go down, it will become 104.25. Correct? So this angle was my 120 degree, this become 107, all the more repel, it becomes 104.45. So if you see, this is just a repulsion logic. There was a lone pair here, it repelled, the angle squeezed. 2 lone pairs squeezed all the more, the angle further went down. Correct? So the normal scenario was tetrahedral. With 1 repulsion, it becomes trigonal pyramidal. 1 more repulsion become bent. We talk about sp3d hybridization things. So with normal thing, it has trigonal bipyramidal. If it is not having any lone pair, if you see phosphorus is not having any lone pair. So all these 5 valence electrons it had is attached to all this chlorine. So it gives the shape of trigonal bipyramidal, this kind of shape if you see. Now if you see, if instead of 1 chlorine, if you remove that and we have something similar to a lone pair, something like this, SF4. So this is the lone pair here, right? There is a lone pair here and 4 other fluid molecules. So if you see, the angle is gone now. It was 120 degree, it becomes 101. The angle is reduced. So instead of 1 lone pair, if you put 2 lone pair, in case of, if you see ClF3, there are 2 lone pairs, right? So the angle is all the more reduced. So 90 became 87.5 degree. So if you have 3 lone pairs, for example I3, it becomes straight. So I3 molecule, if you see, is something like this. Something like this. Because it has 3 lone pairs. So these 3 lone pairs make the whole structure straight. So it's all about the repulsion from this valence shell electron. If we talk about sp3d2 hybridization structures, if you see, it's a normal thing, for example sulfur and this fluorine, 6 fluorines, then it gives the octahedral shape, right? Each of these are 90 degree. But if you remove 1 bond pair with a lone pair, for example in this case BRF5, so I have 5 fluorine, but instead of another fluorine I have a lone pair, then the angle will change. Instead of 90 it become 84.8. And if I put 2 lone pair, they both repel each other and you get a square planar shape. Right? If you see this shape, we get square planar. In this case we got square pyramidal, and in this case we got octahedral. So it all depends on the repulsion from the lone pairs and bond pairs. So just imagine this from the physics perspective, then you will be able to determine the shape of any. You can take the same thing from this the number of atoms perspective also. For example, in this case CO2 or BeCl, since there was no lone pair, it was straight. The moment you put a lone pair here, it becomes bent. You put one more lone pair here, 2 lone pairs here, for example H2O, right? There are 2 lone pair here, it becomes all the more bent. I am taking from that perspective now, the number of bonds. So there are 2 bonds here. The number of terminal atoms, you can say. The 2 terminal atoms here, 2, all has 2 terminal atoms, but it doesn't have any lone pair, so it's straight. It has lone pair, it becomes bent. 2 lone pairs, central atom, all the more bent. 3 lone pairs, central atom, it becomes straight once again. So the first few examples I took, the same example, but in that case I was trying to explain the Vesper theory from the hybridization perspective. Now I am trying to explain the theory based on the number of terminal atoms. So we talk about 3 atoms, 3 terminal atoms now. So for example BCl3. So there is no lone pair, it is my normal triangle planar. The moment you add 1 lone pair, it becomes something like this, the angle deteriorates. You add one more lone pair, the angle is further down. Right? If you talk about the molecule which has 4 terminal atoms, for example methane, everything is fine, there is no lone pair in the central atom, my angle is perfectly fine, it's my tetrahedron shape and all the angles are 109.5 degree. Right? If you have the same 4 terminal molecule things, terminal atom things, but you add 1 lone pair here, the shape change, the angle decrease. If you add 1 more, it becomes square planar. This is 1 lone pair, 1 lone pair. Now there are scenarios where we have multiple shape possible for Vesper theory itself will give you multiple shapes. So in that case, the one with more stable model is chosen. So if you see in this case, I have SF4, but this is more stable. In this case, this is more stable. 5, you see, these repels and is straight. In this case, it is not stable. This case also is not stable. So this is more stable. Here also, if you see, the lone pair is here, the terminal thing. That makes things stable. If your lone pair is here, it will repel this all the more. It will become unstable. This is pretty stable. This lone pair takes care of repulsion of these 2. So the one which is more stable is chosen as a proper model, because if you see here ClF3, you can have 3 models. SF4, you can have 4 models. Right? The one with the more stable shape is picked up. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.